Okay, this is problem 10.3 out of John Taylor's Classical Mechanics. And if you wouldn't mind giving me a like and subscribing, I'd greatly appreciate it. And I'll be posting more solutions out of this textbook and other common physics undergraduate textbooks. So this one says 5 equal point masses are placed at the 5 corners of a square pyramid whose square base is centered on the origin in the xy plane with sides L and whose apex is on the z-axis at a height h above the origin. Find the center of mass of the 5-mass system. So I have something that kind of resembles what we're looking at here. The red dots are a point, and I drew a little coordinate plane there on the base, I guess is what you would call it, the square part of the pyramid. And just to keep in mind, the center of mass, which I'll call R, is going to be 1 over the total mass, which I'll call big M, of, we'll call it M alpha, times, I guess, R alpha, we'll call it. So we can do this for each of these. And with our coordinate axis, it's pretty clear to see what we expect to have. So for example, for the x center of mass, it'd be 1 over the total mass, which is 5 times little m, times, so what do we have? We have times m. And then what we're going to do here, we'll call this, I guess maybe x sub I. So obviously the masses cancel, but that's not really going to matter. You can probably see from the problem the center of mass is going to be at x equals 0. But if you wanted to really work it out, let's do this in a different color, maybe blue. So over here, that would be at the point 1/2 L x hat plus 1/2 L y hat, 0 z hat. Over here would still be 1/2 L x hat minus 1/2 L y hat. And you can do that with all the points here. This one would be, so that's h z hat. Okay. This one would be minus 1/2 L x hat plus 1/2 L y hat. And this one we have minus 1/2 L x hat minus 1/2 L y hat. So those are the coordinates of our different point masses. And if you were to add up your x components, well, you have 2 positive 1/2 L's and 2 negative 1/2 L's. So 1/2 L plus 1/2 L minus 1/2 L minus 1/2 L is obviously 0. So the x center of mass is where we would expect it to be at x equals 0. Now, if you want to find the y coordinate of your center of mass, it works basically the same way. I guess this would be what, 4m, technically. Again, it doesn't really matter. And you can do the exact same thing, and it's the exact same. You have 1/2 L plus 1/2 L minus 1/2 L minus 1/2 L. So this is also 0, which again you would expect in the xy plane. Okay, so then the next thing is the z direction. Okay, 1 over 5m. Now there's only one point mass that has anything in the z hat direction, and it has a mass of m, and its distance from the origin, they say, is just h. Obviously the masses cancel and you're left with 1/5 h. Okay, so then R, I'll call it big R, is 0, 0, so this is in vector notations, 1/5 h. And that's the center of mass of the system. So hopefully that makes sense, and if it does, please like the video and subscribe, and I'll post more videos like this. Thank you.